Okay, in this video, we're going to continue discussing the different ways that we can represent a quadratic relation. In other words, the different forms of a quadratic relation. We discussed standard form in the last video, y equals ax squared plus bx plus c. Today in class, we looked at vertex form as well. So vertex form is when, again, it's another way to connect x and y, to relate x and y. It's going to produce a graph of a parabola. So here's an example of a couple parabolas in vertex form. So again, the first thing to notice is this looks pretty different than standard form, right? So I don't have ax squared plus bx plus c. It looks like I've got a binomial. I've got two terms inside a bracket squared, and then I've got a constant kind of outside the brackets at the end. This is what we call vertex form, and we did a little bit of an investigation in class, and we discovered that, it's named appropriately. When I have a parabola in vertex form, if my equation's in vertex form, I can read out the vertex. So if I look at this black parabola, it's got a vertex of 5 and 7. If I look at this red parabola, I've got a vertex at the point -4, -3. How do these numbers connect to the equations? And what we talked about in class is that the number inside the bracket, if I flip the sign, I've got the x coordinate of the vertex, and the number outside the bracket is the y coordinate of the vertex. So I flip the sign, I get 5, 7. Sure enough, there's my vertex of the black parabola. And the red parabola, again, I flip the sign, 4 becomes -4, and I have -3. So in vertex form, we can read off or interpret the vertex quickly. And the other thing that we discussed in class is that the number before the brackets, the first number on the right side of the equation, still serves that same function of telling us the direction of opening. So when I have a +2, it looks like my black parabola opens up. When my parabola opens down, sure enough, it's beginning with a negative number, just like with standard form. In fact, when we write vertex form, we write kind of the general form, we actually use the same letter A, because A is telling us the exact same information. So A is telling us whether the parabola opens up or down. So if A is negative, if A is smaller than 0, the parabola opens down, like this red example. The black example, A is bigger than 0, it's positive, so it's going to open up. But then what we now learn in vertex form is HK is going to tell us the coordinates of the vertex. So vertex form is A x minus h squared plus k, and it's -h because it's telling us that we need to flip the sign of whatever is inside that bracket. So I'm taking the negative of h, and it's going to yield or allow us to read out the vertex, which is always going to be located at hk. So we're using different letters or different parameters. So in standard form, we use b and c. Now I'm using h and k, and the letters are different because they're telling us different bits of information about our graph. So let's look at just a couple of examples. So I'm going to make up the equation of a parabola that's now in vertex form. And we know it's in vertex form because it matches that general pattern of a x minus h squared plus k. And before I graph it, I already know a few key pieces of information. So the a value is negative. So it's telling me that this parabola is going to open down. It's going to be shaped like an arch. And I already know the vertex of this parabola is going to be at hk. So I'm going to flip the number inside the brackets. And I don't flip the number on the outside. So I think that I'm going to see, when I graph this, a parabola that changes direction, has a vertex there, and it's going to be opening down. And sure enough, that's what I have. Let's just look at a couple other examples, and we'll try to graph them. So now my blue parabola, if you notice, the a value is positive, so it's going to open up. But x minus h squared, I don't see a k value. Well, if nothing's being added or subtracted, that must really be a 0 out there, right? I don't need to write +0 because it's not going to change my equation. So again, my vertex this time is going to be at -4. I flip what's inside the brackets. 0. And because the a value is positive, when I graph this, it should be opening up, which it is. So when I have a parabola in vertex form, I know the direction of opening, but I also now know the vertex. If I'm missing the k value, if I'm missing the number outside of the brackets, then the k value, the y coordinate of the vertex must be 0. And same thing, if it doesn't look like I have an h value, it doesn't look like I have anything in the brackets, well then the vertex of this parabola, my h must be 0, and my k is 3, so my vertex is at 0, 3. Right? We could have written this. It really is the same as saying x minus 0 squared plus 3. But we don't need to include the minus 0, because it's not going to change our equation. It's not going to change our graph. So vertex form is another way that we can write the equation of a quadratic relation, and it's going to allow us to find the direction of opening, and it's going to allow us to know the vertex. So what we're going to do quickly is a couple of examples on paper of the type of questions. Assuming my camera works, I'm hoping it will. There we go. About things that we've learned or things that we can tell from vertex form. We did similar examples in your notebook in class. Here I have an equation in vertex form. So it's a x minus h squared plus k. It may help you to write out your key pieces of information. So my a value is -3. My h value is +3. Remember, we flip anything in the brackets. And my k value is 1. So right away, because my a value is -3, I know that this parabola opens down. And then h and k are going to tell me the coordinates of the vertex. So I'm flipping the number in the bracket. I'm not flipping the number at the end. H and k, alphabetical order. H comes before k. If that helps you remember that x is coming before y. So I've got a vertex of 3, 1. It opens down. If I wanted to find the y-intercept of this parabola, so what is the y-intercept? Well, just like with a line, the y-intercept always occurs when there's no horizontal distance, when x is 0. So if I plug in x is 0, so to find the y-intercept, I can plug in 0 for x, because we know x is 0 at the y-intercept. And now I can evaluate the right-hand side of my equation just using BEDMAS. I'm going to do brackets first. Then I've got to do exponents. -3 squared, -3 times -3 is +9. Then I'm going to multiply. -3 times 9 is -27 plus 1. So my y-intercept is going to occur at that point 0, +26. Sorry, -26. -27 plus 1 is -26. So I was going to do a rough sketch. So it's not going to be an exact graph, but if I was going to do a rough sketch of this parabola, there's my vertex, let's say roughly, I will call that point 3, 1. It opens down, and it has a y-intercept of 0, -26. So without using a technology tool like Desmos, I have a pretty good idea of the shape and some of the key information of this parabola when I was given the equation in vertex form. Let's do one more example. Again, here my a value is +2. The parabola is going to open up. I know the vertex is -5, 6. So remember, I've got minus h and k. And if I want to find that y-intercept, I'm going to plug in 0 for x. And again, depending on the type of calculator you have, we can do a lot of this evaluation in one step. So I've plugged in 0 for x, which is always going to help us find the y-intercept. And I'm going to put that entire right side of the equation into my calculator. And so my y-intercept this time is 56. And so again, I could make a sketch. Again, it's not to scale, but it's a rough sketch. This time my vertex, the point where it changes direction, is 5 to the left and 6 up. So we definitely know it's in quadrant 2. And it's going to cross the y-axis at 0, 56. So again, I can learn some interesting information that will allow me to sketch a parabola from vertex form. The only other thing that we did in class is kind of the opposite. Now, instead of telling you the equation, asking you to find out key information, I could also give you some key information and ask you to determine the equation in vertex form. So we have a parabola and we know where its vertex is. It's negative 3, 8. And I want to find its equation in vertex form. And the only other thing we know is that this parabola has to go through negative 1 and 2. So we want to determine its equation in vertex form. That's kind of our target, so that's kind of our starting point. So I can do a x minus h squared plus k. So our goal in any equation is to link x and y. I've got to figure out values for my three parameters. I've got to figure out, well, what's a, what's h, what's k? Well, I already know that my vertex is h, okay? So I can plug those into my equation. I'll do that in, let's try red. But it's minus h, so minus minus 3. It's going to be plus 3. If it helps, you can think about flipping the sign anytime we're going into or out of brackets, and then plus 8. Maybe I should have put that in red as well. So now all I've got to do is solve for a. I'm going to flip back to Desmos for a second to show you what we've found so far. So I started with this general form of the equation in vertex form, and we figured out that it's going to be x plus 3 squared plus 8. So sure enough, there's our vertex at negative 3, 8. There's actually infinite parabolas that have that as their vertex. So look, for all these different a values, it's giving me a different parabola that goes through that vertex. We were also given one other piece of information. It turns out that this parabola goes through the point negative 1, 2. And you notice that once I know any other point in the parabola in addition to the vertex, there's only going to be one parabola that has the vertex we want and goes through that point. So what we're going to do is try to solve for that a value. So I'll go back onto paper. And what we're going to do is I know this other random point in the parabola. It's got an x and a y coordinate, so I can plug in 2 for y, and I can plug in x as negative 1. And now I have an equation that only has one unknown, which is what we're good at solving. So again, we're going to follow BEDMAS. Negative 1 plus 3 is positive 2. 2 squared is 4, so it's going to be a times 4, which is 4a plus 8. When I move the 8 onto the left-hand side, it will become a negative 8. So I have negative 6 equals 4a. So negative 6 over 4 equals a. And if I reduce the fraction, we could also write it as a decimal. A is negative 3 halves. So as long as I know the vertex, hk, and any other point, xy, I can find the equation in vertex form. So now I've solved for a, and I know h and k. So now I have the equation that's going to connect x and y, and it has the vertex and the point that we want. So if, again, we check our answer in Desmos, what we were told at the beginning of this problem is all we were told is it had a vertex that had to be at negative 3, 8, and then it had to go through this other point, negative 1, 2. And we discovered algebraically that this was our equation. So we can check our answer always with Desmos, which is a good habit to get into. And sure enough, it goes through that point, and it has that vertex. So that's our lesson today on vertex form. Let me know if you have any questions or send me an email. And again, thanks for watching the video.